Hello, today we're going to talk about device meshes and process groups. So at a high level, a device mesh is a way to organize the topology of your GPUs. So for example here, if we have 4 GPUs, we can construct a 2x2 device mesh. And for example, we might want to have tensor parallelism across one of the dimensions and then maybe context parallelism across a different one. And the intuitive way to think about device meshes is that you can kind of think about the dimensionality as a way to group GPUs together into what are called process groups. Process groups, in my mind, is kind of like a group chat, right? So here, for dimension 0, the columns, there's actually 2 process groups that are created, 0, 2, and 1, 3. And then for the first dimension, the rows, there's another 2, 0, 1, and 2, 3. And so this means in practice, when the model is training and stuff, these are going to be the channels with which the GPUs communicate with each other. So in this case, a 2x2 mesh has 4 process groups. But more generally, you can calculate the number of process groups by summing up the mesh sizes. So 2 plus 2 is 4. Now, what's also interesting is to think about a device mesh from the perspective of a single GPU. So in this case, there's 4 process groups, but from the perspective of GPU 0, it actually only participates in 2 process groups. And then the last thing I want to talk about is that these process groups need to have some notion of like ID or name in the same way that group chat would. And so in practice, the way that we calculate the name of a process group in these device meshes is there's actually 2 ways. The first way is you hash the ranks that participate in the process group. So maybe hash 01 hashes to like ABC 1, 2, 3, and hash 2, 3 becomes something else. The other way, and this seems to be the more common way, is that there's this global counter. And so as you're allocating more and more process groups, you're incrementing this global counter, and then you're assigning the index of the global counter to the name of the process group. Okay, so lastly, I want to look at the code. So here we have some code. The code doesn't matter too much. I just want to walk you through the stack real quick. So this is the way that you generally create a device mesh, right? You give it a device type, and then you give it this tensor and the shape of the device mesh that you want. In this case, device is just going to be 0, 1, 2, 3, and then the tensor is just going to be this 2x2 tensor. And if we step in, we can see that in the init of device mesh, we call init process groups. And within init process groups, we iterate through the layout, which is 2x2, and for each dimension, we call init1 process group. And in this init1 process group, we iterate through PG ranks by dim, which is calculated with some math. But if we print it out, you can see that it's basically the columns, right? 0, 2, 1, 3. So if we go back here, it's 0, 2, and 1, 3. And the other thing that was confusing to me that I want to point out is that every single rank will create this group. And this is an internal detail, but it is important, where basically every single rank will construct every single process group. And the key thing is after it constructs the group, it now checks to see if this particular rank participates in this particular process group. And if it does, then it sets this PG name, and then that's what gets returned up to here. And then lastly, like I was saying, these process group names are a function of either the ranks, which if you use hash name as true, goes through this, or it uses this world.group count, which is basically a global counter. Okay, yeah, that's all I want to talk about. Hopefully this was useful. See you next one.